In question 7c, we are to design a circuit that will blink the LED after the counter has counted 64 seconds. The blinking will be at the rate of 0.5 Hz, and the signal should come from the counter outputs. Note that LED is to be turned on by logic 0. Here we need to have a signal indicating that the counter has reached 64. Looking at the binary of 64, we have 0, 1, 0, 0, 0, 0, 0, 0. Notice that bit 6 or QC of U2 turn logic 1 when the output reaches 64 and remain 1 throughout the counting. Hence, QC of U2 will be the signal to indicate that the counter has reached 64. As for the 0.5 Hz, we can get it from bit 0 or QA of U1, as it will toggle every clock, and hence the input clock will be divided by 2. Since the input clock is 1 Hz, hence this output will produce 0.5 Hz. So QA of U1 will be the 0.5 Hz input for the LED logic circuit. Now that we know the two inputs, what we are going to do next is to find out the logic operation. The first thing is that LED should be off before the counter reaches 64. Hence, when QC of U2 is 0, LED should be 1. So what logic operation will produce this? Clearly, it is not an OR gate operation, because the output would have been the same as the input if it is ORed with 0. So it might be an AND operation. But we know the output will be logic 0 instead. So here we need to invert the result. This looks like a workable solution. Again, we need to confirm with the next situation. That is, when the counter reaches 64, LED will blink. Hence, when QC of U2 become logic 1, signal QA of U1 should appear at the LED output. Based on this, however, the inversion of QA appears instead. Nevertheless, this can still work because what we want is to blink the LED. Never mind the turning on and off is inverted. Hence, it is confirmed that we can use a NAND gate to perform the task. So here is the design for the LED blinking logic circuit.